So I'm Mike. I work at Yahoo, where I'm a UI architect in their ads and data division. So what this means is I look at a bunch of our Ember-based apps. We have 20 apps in the ads and data division that are written with ember.js. And across the whole org, many more. I also, with Tracy, run a meetup in the South Bay called Modern Web UI. The aim is to foster cross-pollination between the framework communities. You should definitely check out our website, modernwebui.org. We've had some amazing talks over the past couple months. In my free time, I like to do a little open source work. Hopefully we'll be able to continue doing that, mostly in the Ember ecosystem. So a little more about what we do at Yahoo. As I said, 15 or 20 apps in the ads and data division. There are as many as 50 or even 70, we're losing count, across all of Yahoo. It's really taken hold, especially for a lot of very data-driven, ambitious apps. We have 70 developers who day-to-day write almost completely JavaScript and use Ember. And the flagship app that's sort of driving this innovation, and this is where a lot of our internal add-ons are extracted from, it's huge. It's about 70,000 lines, including tests. What's that? No tests. 70,000 lines without tests, Steph is telling me. So a lot of Ember going on at Yahoo. And so today, as I said, I'm talking about user-perceived performance. So first, I'm going to go over what is user-perceived performance? Why am I calling it user-perceived and not just performance? There are a lot of performance talks out there. We're going to go over a little bit of how to instrument your code, how to measure performance. Then I'll dive into some lessons, some pitfalls we've hit at Yahoo with our Ember apps, and try to share some of our learnings there. And then finally, I'm going to finish up with some interesting patterns, some UX patterns that can be applied when you've kind of gotten as far as you can get with the real performance issues. So how can you create the perception of things being more responsive without actually improving what the profiler or timeline actually says? So user-perceived performance. We should start by talking about user perception. And there are a couple key times I want you guys to remember. Anything under 100 milliseconds, according to patterns that people in human-computer interaction refer to, anything under 100 milliseconds is instantaneous to your user. So that's an immediate response. And you can get up to a full second while making it still seem like everything's causally connected, making it seem like that button push resulted in this dialogue coming up. Going beyond that, the wait is not only noticed, but it starts to become confusing. And above 1 second, it's advisable that you start using loading spinners and trying to give the user some feedback that a long-running task is happening. When you get up to 10 seconds, you risk losing the attention span of your user. And this is like when your user is about ready to get up and walk away to get a cup of coffee and then come back. And at that point, it's all the more important to give more feedback and ideally to let the user kind of proceed about their business while something continues in the background. So this is a great baseline, and this hopefully helps clarify what I mean by user perception, because it's all about how it feels, right? So when dealing with single-page apps, compared to server-side rendered apps like in PHP and Rails, there are some advantages, some things that work in our favor for user-perceived performance, and then there are some challenges that we have to deal with. So a clear advantage is that our servers are doing less. They're not rendering HTML anymore. They're generating JSON. The work being done, both in terms of rendering and fetching data, it's incremental in nature. If a user is changing between two child views, the parent view remains intact. There's no need to refetch that data. Whereas if you boiled the ocean again, you'd have to go back to the server for another round trip. And then finally, this is sort of often overlooked, but in a single page app, we get to control the user experience of waiting, right? So if you're writing, a basic PHP app, you hit, submit form, and the page goes blank, and the address bar in the browser starts filling up, and we don't have control over that experience. You can only do so much. So some challenges is that for Ember apps today, your initial page load is probably going to be longer than it could theoretically be if you were just dealing with what's on the login page. We have to send our whole app to the user. All slowness appears to be in the UI. This is something people have come to me at Yahoo about over and over. They say the UI is slow, the UI is slow. If the loading dots are up on the screen, odds are we're waiting on something to happen in the back end. Rendering is not the bulk of the work being done to get data and display it on a page. But still, people feel like this is part of the UI. And then finally, the API loses a little bit of context here. It becomes a resource that the UI consumes, and the API doesn't necessarily know exactly which page is being viewed. It doesn't know the context that the user is in, what action is being performed. It just knows, I've been asked to perform these operations, and here are some contracts. So I will talk about how this presents an instrumentation challenge down the road, the fact that the API does not have context anymore. And we all know that performance matters. We care about our users' experience as UI developers. It matters to business too. And to play it safe, I'm not putting any Yahoo numbers up here. These are publicly available, asserted page load consequences here. So Amazon apparently at one point did an experiment that resulted in a 1 second increase in page load time. They found that it would, if widely deployed, result in a $1.6 billion annual revenue decline. Big deal. Google performed an experiment a few years ago where they, instead of returning 10 search results per page, they returned 30 results per page, thinking that that would be a convenience to users. They don't have to go to the second and third page. The cost of this was a 0.4 second page load increase, and they lost 8 million searches a day. And think about how much ad revenue that is. Think about how many users are just less engaged because the time to first responsive app was reduced by such a small amount. So, okay, we know what this user perception thing is. We know that it's important. So now I'd like to talk about how do we measure it. And this is something that I was tasked with at Yahoo. We want to come up with a way of instrumenting performance system-wide. And on the server side, this is a well-understood problem. So what you see here is a screenshot of Skylight. And if you don't know, this is Tilda's product, where you can plug their efficient data gatherer into your Rails app, and it will figure out how much of your time is spent doing which database queries, and so on, and give you feedback as to what you can do to help improve that situation. But beyond that, we want to know, across this whole system, what's happening. What's happening in the network, what's happening in the API, and what's happening in the database, and everything in between. So these are all areas where you can run into snags that will kind of upset your users at a subconscious level, right? And if we think about that in terms of pieces, if we imagine that this is a timeline here, we've got the API, and think of this as a response, right? A request is just sort of asking, and then the work is done in returning some data. So which database calls, database queries are made, how much time is spent doing business logic in the API, and then that data is transmitted over a network, and finally it reaches the UI, and the UI does some stuff. If we can just instrument this a little bit, we can actually do some simple subtraction and figure out some more confusing areas, right? Like measuring non-database API time, that's useful. That's probably business logic, or if you're using Rails, that's the cost of active record potentially. So this will give us a lot of insight into what's going on. On the UI, this is sort of our world here. This is what a page load looks like. You have a top-level transition, and you may enter 2 routes, and the route will take, the model hook for route A will take a certain amount of time, and then the child route will start loading. And as part of that, you have some views rendering, and that takes some time. So this breakdown here, this gives us an interesting thing to study in terms of looking at, why is my app slow? What in particular is slow? So today, I'd like to let you guys know that there's an add-on for this. In its basic form, currently instruments only the client-side stuff. It will, on route transitions, give you an event you can listen to that will tell you, this route took this long, this route took this long, and even the view rendering times associated with the correct routes. This is something you could send off to Google Analytics or whatever you like, and study it further. But this will let you guys know, what are your users really experiencing? And this is a much more valuable way to study this kind of number than benchmarks or running your test suite against it. This will tell you, what are your users really seeing? They may be at different parts of the world. They may not have an internet connection as fast as yours. And you want to know, what is the experience that they're getting? So once we lump in some information from the API, right, which has lost context in the single page app world, it doesn't really know what page is being viewed, what the state is being used for. If we just transmit that along with an API response, this is what we hope it's going to look like in the near future, where you can actually say, this route sent out these API calls, and this amount of time was spent querying the database, and these are the views that were rendered. And this gives you a really nice cross-section across your whole system as to what's going on. And on this, we can expand to talk about, network time, like what is the UI's perception of how long this API request took versus what's the server's perception. And the difference between those will tell you, what's happening with your CDN. But this is something we're going to start using internally, and we hope that some of the rest of you guys will check it out and give us some feedback so that we can start giving Ember apps the deserved reputation of being very, very performant. They certainly have the potential to be now.
More importantly, we can start blaming the API developers.
Yes, Steph says, more importantly, we can blame the API developers, deservedly so now. And beyond the add-on, beyond Ember Perf, make sure that you're well acclimated with the tools you already have, which are the profiler in your browser, your dev tools, the timeline, the network tab. The Ember Inspector is interesting, and the Render Performance tab can certainly help you see relative differences in rendering time. But the overhead of having the Ember Inspector there, it's its own Ember app. It's currently collecting some data in band as you're rendering. So sort of the act of observing rendering performance can affect your rendering performance. So definitely make sure you take those numbers with a grain of salt. But it's great for looking at, here are your biggest sore spots versus this is stuff that shouldn't be too much of a problem. All right, so we've talked about instrumentation a little bit. Now I'm going to dive into the next section of my talk, which is lessons learned from Yahoo. And it's tough to weave this into a story here, but I think it's so important that we share this knowledge, having built such a huge app. So you'll pardon me if it's a little bit jumping around. So from the project setup, which is non-code stuff, make sure you turn gzip compression on. It probably comes almost for free. You may already have it on. Make sure if you have an image-heavy app, you're using the size of image that you actually need and not a massive retina wallpaper shrunken down to a thumbnail. And then the most important thing you can do, right? Keep up to date on the framework releases. There are many, many smart people working hard to make sure HTML bars is fast, and Glimmer is fast, and Ember is more performant. And if you fall behind, you don't get to take advantage of that work. So odds are this is probably the most effective thing you can do for your app's performance is stay up to date with the framework version, with the release. All right, some more tips here, and each one of these certainly has a story behind it. Over the past 2 years, I've spent working with Ember at Yahoo. It pays to have an awareness of the cost of your data. So UI developers, it's easy to live in browser world, but you should know if the API call you're making is you need 6 database joins in order to create the data set that you need to respond to that request with. Load what you need. I seriously, this per page equals 200, that is from old Yahoo code. We have infinite scrolling tables. People were noticing performance problems. Only 30 rows are visible at a time, and we were loading 200 rows for the initial load of the table, which is obviously overkill. And that was a very easy optimization to make there. So in terms of loading what you need, who here knows Pretender or Ember CLI Mirage? All right, so I ask because Pretender is, I believe, inside Ember CLI Mirage. Something you might overlook about Pretender, a hidden advantage, is that it forces you to explicitly declare which API calls are necessary for a given page load. And so if someone creeps in and accesses a relationship, an async relationship that you may not necessarily need, you'll be alerted to that. So it pays to kind of scrutinize, is this call really reasonable for this page? We have many bugs today that are of this nature, where somehow someone's accessed something that is lazily, fetch data from an API and it's just not needed, and that hurts performance. And then finally, this is an interesting one. It's okay to keep loading the stragglers. So we have a particularly complex page in our ad platform. And there's one element on the page that takes about 10 seconds to load. And there's not much that can be done about it. It's very complicated. It's very ad hoc. Nothing can really be cached. So the solution here that we took was get the rest of the page loaded, let the user start interacting with things, keep a spinner going there, and the perception is this is not a problem anymore. Users aren't complaining anymore. They feel like the app is ready and they can interact with it, and then this other thing comes later. So that's, for certain situations, that's a good option. And then here are the typical performance pitfalls that we've hit over and over. Observers, huge performance problem. That's this sloshing problem where the app sort of renders and then a bunch of stuff changes in data insert element and then re-renders. Certain things like triple handlebars are inherently slow, and unless you absolutely, absolutely need them, avoid them. And then the last performance pro tip I want to share with you guys has to do with routes. So who here has typically structures their routes sort of head to tail like this? Nobody. Awesome. So some of you are lying out there. So the idea here is if the information needed to send a request out is present in the dynamic segments of a URL, there is no reason to wait until parent routes are done loading before you start making that request. So here we can cut this down from 400 milliseconds to 220 because we can already build the URL necessary. We can already send that query out. And there's no need to kind of chain these things in serial unless the second request needs information from the first response in order to be sent out. This is probably what you should be doing. All right, so finally, last section here is this is when you're at the bottom of the barrel and you don't think that you can improve anymore, the UX tricks. So YouTube, video uploading is inherently slow. There is no way to make the internet connection of your user faster. So what they let you do is, as the video is uploading, you can proceed about your business and you can fill in the details, you can tag, you can even complete this process and the video will keep kind of uploading in the background. And then it'll transcode and you can see how this task is progressing, but it's not blocking, right? So this next one here, I couldn't find the screenshot, but I first saw a loading screen that presented me multiple messages in the mobile version of 37 Signals Basecamp, where it would say, you know, we're loading just a few more seconds, and it kept kind of cycling through different messages. When you engage with your user a little bit, when you make this a more interesting waiting process, you're not staring at the same thing. You're not there just like feeling like you're the faster moving thing and the computer is what's slow. You sort of are a little more forgiving about the loading process. So the second Ember add-on, right, is all about getting something on the screen immediately. So this is a problem we have in this big app at Yahoo. We need a lot of data up front just to get like the nav bar and everything loaded. So sort of the bar we have to pass, it's about 1.5 seconds this API call takes, which one could argue is a problem in and of itself. But what we're opting for and what we're going to start doing is putting something on the screen in index.html that will be there telling the user the app's downloading, the app's initializing. It will render right away. It will render while your vendor.js and your app.js are still in the process of downloading. And at least that saves you from showing your users a white screen. It helps them feel like they're in the right place. I know I have the feeling, especially if I've just updated something, it's like, did the deploy even work? Like I open up my network tab, am I requesting things? Are these the right fingerprints? So this helps reassure people that yes, they're in the right place. Please wait a moment. So Ember load should be a drop-in, way of doing that. And as soon as your application view renders, it'll rip out the loading widget, however you want to customize that. So Facebook's mobile app uses dummy content. You can see that to the right. It sort of has the structure of what their page will look like, but it comes at no cost. And then the last tip that I actually know from a previous job is like smooth and honest progress bars. Honest means don't get to 90% and then stall. Yeah. And like how frustrating is that, right? You want something that the user feels like the app's working, it's steady work going on, and it actually completes when it says it's going to complete, and it doesn't lie and say it's going to take 3 seconds and it takes 30. So the last thing I want to say here is we have had massive performance improvements delivered to us by the contributors to the framework and contributors to Ember CLI. HTML bars is huge, Glimmer is huge, and hopefully with these tools here, we can start giving Ember a reputation for being a framework for first-class user experiences, right? Where we can start studying this data, finding the sticking points, and hunting them down. Because really, it's on us now. We're not resting on something that is slow. We're resting on something that's really, really fast. So we have to go in and kind of do our good work now. All right, that's it. Any questions? Yes.
So for the dummy page loads, it sounds like you're going to pick some initial CSS and JavaScript that has to load first before you can download the initial, and then you queue up your additional CSS and JavaScript. My question is, what is the essential JavaScript that jQuery? So
I actually, the dummy page for this add-on, and people can do whatever they like, but like the demo page. Oh, sorry, let me repeat the question here. The question is like, what are the particulars of this sort of the loading widget, and what are the resources necessary? If you can get away with just CSS and HTML, you will not have to download anything else. And that will make it so that as soon as index.html hits the browser, you have a CSS animation that's starting. And so that will actually save you from having to think through, is this the resource that's going to download first? And do I have my dependencies in place for the complex loading situation? If you stick to what the browser already does out of the box, you don't even have to think about that question. Yes?
Talking about the smooth progress bar, there are some easy things you can do, like having a progress bar depending on the number of tasks that you have to achieve. Some of them you don't necessarily have to control about how long it's going to take. For example, you can make a guitar request. You can rely then on the progress API, like your code. You have other tips to be more honest.
So the question is how do you create an honest and smooth progress bar? It is a two-sided problem to solve, right? You need something to report progress in order to be honest about it. And the typical way of doing it, I believe, and the name escapes me of the terminology for this, but you start the download and then you have a second request that will periodically ping for progress that will tell you, how many bytes have been transferred or what's the progress of this task. Beyond that, I would just say steer clear of obviously dishonest progress bars, which will rush to 90% and then wait until complete and then advance through. That will actually piss your users off pretty badly. Yes?
Have you experimented much with asynchronous script loading? That's something we did. We have some content rendered server side, and so we saw our numbers increase as far as the load event, but we didn't know if it necessarily helped user experience.
I don't have any specific insight to that. We just have app.js and vendor.js, and everything's rendered on the client. So
Our bottlenecks are honestly the API. It sucks.
that's okay. None of our API developers are here. Steph, you can go nuts.
So speaking of that, your plan is to have timing metrics come with your API calls down to the client so you can mix that in with your metrics?
Yes, and the idea there is that the API doesn't know what's happening. It doesn't know the workflow it doesn't know the process that the user is going through. And so the idea is to, in the meta object, pass back, some particulars about how long did this take to form? Which services did you have to contact? And then the UI then has the whole picture and can beacon that off somewhere. All right, thank you guys so much.